Okay, this is a practice for a voltage follower where you have an input voltage and an output voltage. This is an instrumentation amplifier MCP604 or MCP602. The MCP604 has 4 op amps on every chip. On pin 1, 2, and 3, you have this op amp, which I'm calling A. Another op amp is on these pins, 5, 6, and 7. The third one, op amp C, on 8, 9, and 10. And the fourth one, D, on pins 12, 13, and 14. Notice that the voltage is pin 4, VDD is voltage, and VSS is ground, is pin 11. Okay. Every op amp has a mark here to identify pin 1. So pin 1 through 7, pin 8 through 14. And in this op amp, I'm only using pins 2, 3, and 1, which is this one, the one I'm using. So using a trim pot, which can be from 10K to 100K, we adjust the input voltage, and the output follows the input. And you have to make a feedback loop right here. And this op amp, the voltage follower, is used to match impedances and in other circuits. So why? Because it has a high input impedance and a low output impedance. Once you know how to use a voltage follower and it's working good, you have to fill in a table, and this is your table. So where you will be applying 0 volt, 0.5, 1, in increments of 0.5 until you reach 5 volts. So you have to put them here, the measurements you're taking on the output. The input is here and the output is there. Now, another op amp is the non-inverting amplifier. The non-inverting amplifier is this one, where you have the MCP604, letter B, and you have 2 resistors in the feedback loop, which is R2 and R1. They control the gain of this non-inverting amplifier, and the gain depends on this equation, which is the output is equal to 1 plus the ratio of R2 over R1 times V in, the input voltage. Okay, so once you finish the first circuit, this one, in the voltage follower, you make the connection of the voltage follower. This is your input, and you apply your input to this input, to the non-inverting input, and the output to the input. And right here in this configuration, to measure the output voltage here, you use a voltage follower, which is a C. And notice the pin numbers, 8, 9, and 10, because 8, 9, and 10 are right there on the right side. So the gain is 1 plus R2 over R1 times V in. So this is equal to saying that because this is the gain, the output voltage is the gain times V in. Or BO, the gain, we can say it is a slope, BOCM times B in. Or if we call these measurements on the y coordinate, we call them y, and this x, you can say that you have an equation equal to A equal to mx. There's no plus b because we are starting from the origin from 0. Okay, and so you have to, in this op amp, we are we are putting 2 equal resistors of 1K, R2 and R1. Therefore, your gain will be equal to 2. 1K over 1K plus 1 is 2. So the output is 2 times the input. That's a gain of 2. So you fill in your table with those increments up to 2.5 volts. That's the maximum voltage you will be applying with your trim pot, with this one. And your maximum output will be 5 volts. There's no reason to keep incrementing the voltage because the output will be 5 volts. It'll be saturated. And with those values, B in and B out, you do your graph, and you will get a graph like this. Okay, so this amplifier has many applications in many types of sensors, because sometimes you might have a sensor right here which provides a voltage in a range that you don't need. For example, it might be a voltage from 0 to 1 volt, and you need to amplify to 2 volts or another scale. So you just change the gain. Okay, so there are applications to do that. We will see those applications later. At this moment, first you need to test, as I said, you need to test your voltage follower. Okay, test your voltage follower. Once it is working with that table, then you apply that output from pin 1 to pin 5 and 2 resistors, R2 and R1, from pin 7 to pin 6 and from pin 6 to ground, and another voltage follower to isolate the output. And right here you will measure the output with a voltmeter. Okay, that way any output that you put here, a resistor or a voltmeter, will not change the gain, will not modulate the gain of this op-amp. That's why you need two voltage followers to isolate the output from the input. Okay, so this is the topic of voltage follower and non-inverting amps. Okay, thank you.